of Machine Learning for NLP by Dr. Damodar Reddy, sir. We welcome you, sir, again to this session, ATAL FDP session, sir. Good afternoon, sir. Damodar, sir.
Good afternoon, madam. Please.
Good afternoon, sir. So, we already have the session on research scope in natural language processing on day one second session by Dr. Damodar Reddy, sir. So, we already knew that Dr. Damodar Reddy, sir, is presently working as an associate professor in Department of CSC, National Institute of Technology, NIT Goa. So, I'm handovering the session to the sir to have the talk about the trends and application. Over to you, sir.
Ah, Thank you, madam.
Thank you, sir.
So I'll share the slides. Yes. Can you see the slide? Please confirm.
Yeah, sir. Audible and your presentation is visible to all the participants, sir. Please go on, sir.
Yes. Now, like we have seen the basic introduction and some motivation and various applications in the previous session. Now, let me just give a brief discussion and why do we really need machine learning algorithms for NLP. Then we'll jump into various applications and part. Today's session mostly we try to cover some neural network and some swarm intelligence type models, which we try to use from MLP, from machine learning for your NLP applications. So, like we already seen, many of you are working on in NLP, and some of you are using machine learning, some of you are not using machine learning. So now, just let us discuss why do you really need machine learning models for natural language processing. Tell me, anybody? Now, can we conclude that without machine learning, no NLP is there? Because when we say trends and applications, this is, I mean, can't we have some different applications using, some other model, not just a conventional advanced machine learning model? Why can't we go for other, statistical or any other type of models where some better solution can be identified? Why machine learning models for this? Tell me. Anybody? My question, straightforward question is like, if you have an NLP problem, do we really need some machine learning models compulsorily there?
Good afternoon, sir.
Yes.
So, traditional NLP methods that use some linguistic knowledge like rules, grammar rules, and that is possible, but
Yes.
they may not be scalable with the current trend in data explosion. They cannot handle the large amount of data. So, in that sense, machine learning models can do better.
Yes, you are right. This conventional analytical modeling and all maybe you can perform without machine learning. But the moment we come now, see more 90%, at least 90% of the research in NLP, they are using directly or indirectly some machine learning models. Up to what extent, that is different, of course. But the moment we come to this domain of natural language processing, it was existing. I mean, but with the evolvement of machine learning modeling happens, people are, focusing much on using machine learning for NLP. It does not mean that you can't have an NLP application of your choice without machine learning model. You can. But most of the, researchers, why they are doing is mostly for optimization purpose, and then some other computational purposes and various other reasons. When you use this machine learning model like some neural network, conventional feed forward neural networks, deep learning models, extreme learning machine, and then other type of the CNN type model for different, of course, image processing and application where the NLP problem can be identified. Some swarm intelligence model, fuzzy logic, rough sets, information sets, and other unsupervised supervised learning models. They are using, frequently. Now, but which machine learning model I have to choose for the for the selected NLP problem? Tell me, somebody. Can I take any machine learning model for my NLP? Because why I'm asking this particular question is, whenever I see the scenario where people are working on some NLP related problems, I've seen like somebody use some bias-spread optimization algorithm, somebody use some genetic algorithm, somebody uses some deep learning. And I've seen, and I've asked once, I was evaluating some MTech dissertation. Like I've asked him, why you are choosing some deep learning model? Why not you go for some conventional neural networks? And somewhere they have used a neural network with some bias-spread optimization algorithms and all those things. So then he was telling, I've seen in some paper, I'm just following that. Somebody else said, yeah, I have used deep learning because it's high chances for recognition or acceptance of a paper or manuscript. And I've seen that scenario, of course. But the answer he has given was right, because when you use some deep learning applications for NLP, the acceptance rate may be high. But does it really make sense? Because please try to understand the motivation. Not every NLP application requires machine learning paradigms. No, certainly not. Fine. There are some, NLP problems you can conveniently solve with other models. You need not always go for a machine learning model. Of course, but most of the requirement is obviously there because there is a large amount of data, some text volume data sets you have, and then other type of data, some image data sets sometimes, and then some real-time signals you are collecting for some other application, maybe some biomedicine or medicinal application. So obviously there is a requirement of that. Most of the requirement is there, but does not mean that there is no NLP application or problem without machine learning. Okay, why I'm just pressing upon this point is, at the end of the session we can't conclude that without machine learning no NLP is there. It's completely a blind statement. Okay, machine learning has become part of the life, like you can say. Now, I'm not giving an introduction or motivation for machine learning here. I'm telling the need of the machine learning. But tell me just one word reason. You tell me, why are we really going with machine learning everywhere? The reason is mostly optimization, computational efficiency, accuracy. All these 3-4 crucial parameters, because of which we are going. Even if you talk about some security protocol, also we really require machine learning model now. So it has become some undividable aspects in each and every research domain. But somewhere I have seen it is polluting also, kind of. Okay, don't quote me. Now, am I audible?
Sir.
Yes, yes. So now there are plenty of applications. So like we start with one application and we'll go next to some other application of machine learning. Mostly we start with some deep learning, genetic algorithm, fuzzy logic and all. So we just start with some specific application when we talk about these machine learning models for some human computer dialogue systems. Can you give me a couple of applications where exactly these systems are needed? Now I will tell exactly at the end where, in the sense at the end of this slide, not end of the presentation. I will tell you where we can use the machine learning model in this. Of course, many of you know. Now tell me some human computer dialogue system. Tell me some of the applications where we can use. Where do we use this type of system? Human computer dialogue systems or human computer interaction models and type systems. Because today I will show one such hardware device which we use for such human computer dialogue system. It is in there. I will just try to give a brief explanation of that. Before that, tell me any other real-time application where we can use human computer dialogue system other than the chatbots and all. Is the question clear to you? Hello? Yes. Other than the chatbot type applications, can you tell me any other applications where these human computer dialogue systems can be used? No?
As an expert system?
Expert system and recommendation system, that's of course we can map it to them. Any other simple real-time application can you give? Then I will add where we can use some machine learning part and others. Right. Human computer dialogue systems, right? It's a simple number of plenty of applications are there. Okay, so let me give some e-commerce application. I have such a dialogue system. I will ask something like Alexa, whatever it is. Okay, is Alexa a kind of human computer dialogue system?
Yes, sir.
Yes. Now, if I go with this some e-commerce application where I am using this type of dialogue system, I will ask like I want to search for a certain type of goods or items. Then it will ask according to our, see, the moment I give, I mean, I just, if it gets my audio or voice, tries to identify what exactly my age group or something like that, or it might give some possible questions like which type of, which color type of goods you want, and what is the cost and all those things. Then some specific application related questions you can ask. Then I can give some information. It will make some linguistic or some analytical processing, and then it will see what it will recommend. Kind of recommendation system. I mean to say, like we'll say, using human computer dialogue system. But where do we use the natural language processing? What and all the input, voice input, how the voice output can be generated based on what? Based on, tell me, what and all we are using here, that once we get a voice input, okay, once the computer get a voice input, then we are going to make speech recognition and send some language analyzer, then some query processing, some database processing. Then we try to construct a replay in text form. Then text replay. Then there's something called speech synthesizer, according to the, I mean, voice responses. Then the speech, that is, we have the voice output. So there we use some speech models, some grammatical and semantic models, and then some information database we require, and some punctuation and pronunciation rules we need to follow. Now, tell me where we can use. Now, certainly it's a kind of NLP application, obviously, because we have voice input and we are converting natural language, and then we are trying to make the speech recognition. Of course, obviously, convert to spoken input to text. That itself the natural language. Then text analyzer we have. So this is a fantastic application using natural language processing where you are developing human computer dialogue system, okay, or the human computer dialogue system is developed based on the natural language processing. Okay, so tell me where we can use machine learning part here. I mean, you can only, I mean, confirm this, where we can use some machine learning models. Tell me. Can you hear me?
Yes, sir.
Yes. So see, convert spoken input into text, where we really require this natural language processing, right? Based on which text. Now, does it really need some machine learning models?
Yes, sir.
Okay. Now, you see, a person says some particular word. Now, when the audio signal is being, I mean, recorded or reached to the computer,
Might be the main application in the calling system. Caller.
can you recall, madam? I didn't get your.
So this application might be particularly used in calling whenever we call to the someone. And this can be converted into the text.
Yes, that can be there. Now, which machine learning model exactly we can map? That's one. Now, what I'm asking. For example, speech recognition, language analyzer, so on so. Now we are asking at trends and application. Now we are trying to integrate or implement this system, human computer dialogue system, with the help of some machine learning model. Now we have speech recognition. There is a speech recognizer. Okay, speech recognizer. What do you mean by speech recognizer? When the audio voice input comes to the processor or to the computer, which perform the speech recognition, the speech recognizer, what it does, converts the spoken input into text. How it performs the spoken input? First, you are training something like, see, when there is audio signal of certain band wavelength or some certain frequency range, it comes. Then what happens? We are trying to map this word, possibly 90% equivalent to some particular, I mean, word like the, and then some particular keyword like computer, something like that. So, which particular word of the trained supervised data this particular audio signal or voice input is matching with, then accordingly the speech recognizer will analyze this particular word corresponds to this text, or this text corresponds to this particular word of the input document. Then accordingly, because speech recognizer is very, very important. Why? How to get the queries from the users of the e-commerce application and how to get this information such that they can make this linguistic processing can happen, right? So there we can use some machine learning models, some neural networks, some fuzzy logic. Now tell me, what we can use here most? Which machine learning model you prefer here? Tell me. Can we use some neural networks here? Hello? Hello?
Yes, sir, we can use ANN or CNN or sklearn, etc.
So use some neural networks or any other type of conventional or some deep learning models here, because already you have trained your processor or your network such that what it does identify the exact type of words being given in the voice input, and then how we have the match to that, and then we can interpret what is the exact statement or what is the query from the user that is connected with the e-commerce application, right? Then we have next language analyzer. Whatever the text you have generated from the speech recognizer, they are going to have some language analyzer. Now what this language is, you try to extract some meaning from the text. Tell me where we can use some machine learning models here. Now I'm talking about the general trends, because the title is like trends and application. Now I've taken an application and I'm just giving the trend, what type of models people are using. Now tell me, language analyzer, what type of machine learning model it requires? Speech recognizer we have seen. Language analyzer, you tell me. You try to extract meaning from the text. Now what will be extracting the inherent meaning from the text that is recorded or converted from the voice input? Tell me. Simple logic. See, it is not exactly like that, but it is kind of feature selection or feature extraction models where we try to map it here to be used by this language analyzer, where we can extract some features and then we can make some knowledge data discovery happens. Because features define the classes, right? Obviously. Therefore, you'll get some meaningful objects or meaningful sentences from the natural language that is being generated from the voice input text, right? So now these two phases like speech recognition and language analyzer, they will just already you have natural language processing started here. The moment you have this converted text is into hand, how do you make the feature extraction, some principal component analysis, or any other deep learning with autoencoders, or any other type of some bias spread optimization algorithms you can use for feature extraction. You can use some neural network with a combination of bias spread optimization algorithm where you can make these better features with the help of which you can generate. Now what? Finally, the computer where you are making the query processing after these speech recognition and language analyzer happens are implemented or executed. So you have certain queries from the database, then construct a reply in text form based on what these are the queries. This is the meaning of the sentence, what is given by the user. Then I'm going to make this query processing happens from the database, whatever is once you have queries database, right? What do you mean by queries database? You tell me. Once you get the meaning of this particular language or a sentence that is already encoded in the form of a natural language from the voice input signal, obviously what happens, you will come to know which particular concern or a question it corresponds to the given text from the user input who is using the dialogue system. Obviously, you'll come to know with this query, this particular database you have, these are the possible options. You can give them, you can recommend. I don't mean to say exactly as a kind of a recommendation system, but of course you can call it as some sense. Fine. Are you following me? If you see each and every phase, I'm giving a machine learning model where we can possibly use it and synthesize. Right? Of course, then convention I'm talking about, according to your application and requirement, you can keep on changing them. Okay, in place of deep learning, you can keep some external if it is computationally efficient if you want to be. That's all difference. Different models. But you see, every phase of this system which you are developing based on your natural language processing, we are going to use this type of machine learning model, right? Not only one phase, every phase you are using, right? So finally, when you have the text replay comes based on a query database, now we are going to make some speech synthesizer, which will try to get some voice response that will give you to the voice output, which is given to the user using the human computer dialogue system. Okay. So where you are using speech models and this grammar semantics and then information database and then other rules which are required. Okay. Of course, one example that e-commerce, whatever I have asked, this there are plenty of examples. Can you give me any other example here? Can you give some? Okay, I'll give a hint. Like any medicinal example, medicinal application, healthcare technology system. Somebody?
No, sir.
Now, see, if with the problems faced you have in your pandemic situation, obviously we are in need of contactless treatment, contactless diagnosis, and then contactless. I mean, everything has become contactless. Now, let me define a virtual patient monitoring system, a kind of human-computer dialogue system, where, of course, there is no doctor. There is a, I mean, a well-trained computer or a processor that is trying to treat the patients, or at least that is trying to advise the patients. Because this human-computer healthcare technology systems cannot replace the doctors, but they can serve up to some extent. We are using the machine learning at the max. Fine. So obviously, what we can do, we can try to develop a kind of same human-computer dialogue system for virtual patient monitoring system or virtual patient diagnosis or treatment type of applications. Do you agree with me?
Yes, sir.
Yes. Now, again, how the computer or your processor works here is a pre-trained models of your neural networks or deep learning where you can encode such that they will ask when you have this system, I mean, turned on, you can have these options like, may I help you? Oh, yes. Then what is your problem? You can say like heavy cough, and then uh, heavy cough, sweating, and then some stomach ache, and all these symptoms you can give. Then they will ask what is the age group and certain questions. Now, if you can observe, these questions are actually interrelated such that you are converging to a disease. I mean, diagnosis of a disease, and you can give your symptoms. Finally, it will say your symptoms mostly matching with the following possible diseases. Possibly, may not exactly. Then it can recommend for these possible things, so and so particular doctor or hospital could be consulted, and as an immediate first aid you can have uh, some possible medicines can be suggested as immediate reference. Kind of application you can also generate, again where you require this type of trained models of machine learning, so maybe like neural network, or when the search space is enormous, like you have large amount of search space, because why there are so many medicines available in the market, it's difficult to distinguish kind of based on the diagnosis, in a virtual environment. Therefore maybe you can use this type of models like some genetic algorithms, swam intelligence also. And sometimes when you are uncertain to talk about or to predict the possible symptoms for a candidate, maybe you can use fuzzy logic, because in such instances fuzzy logic could be one of the most key component. Yes, please. Like that. So plenty of applications. It's not just a one NLP problem you can solve easily. Based on this NLP processing, you can use plenty of applications like this in human computer dialogue system. This is actually a little broad human computer dialogue system within which a lot of applications of NLP, using NLP, not of NLP, using NLP can be performed here. Are we clear? This slide, can I go next? Hello? Any doubts here in this slide?
No, sir, it's clear.
Okay. Now, all those who are trying to develop such models, now, like people can ask, like whether I should use some machine learning models, like whatever I discuss for speech recognition or language analysis, or any other type of. You can use anywhere or either phase. Wherever is possible, you can. Can you see the next slide?
Yes, sir.
Yes. So what are all the various? I think I already discussed. There are many. Systems. This I already discussed. Like we have some. Um, when you have simple voice communication with message, we can have different type of application already. We have an interactive answering machines, and then voice dialing of mobile telephone, some call center before type application, and most importantly, vehicle systems. Now, what about in vehicle systems? Do you really require natural language processing? Tell me. Guess what type of applications we can perform here? then I will tell where machine learning can be used. Tell me, somebody. Vehicle systems.
So automatic car.
Yes, perfect.
Automatic car driving.
Yes, automatic vehicles, automatic cars and all, where you can use this natural language processing heavily, and particularly that type of applications where you ensure, I mean, no latency, I mean, no error. Obviously, you will be, I mean, you'll be needing highly accurate and natural language processing models, because the moment you say turn left, it can't go right side, or it can't understand. I mean, such situation should not arise. So these high latency applications, obviously, we require I mean, this emergency applications, we require highly accurate natural language processing models. Okay, and then many other applications, like kind of voice command based vehicle system for different. And it's not only automatic cars, even you can say like keyless vehicles, where I can simply command my vehicle, I mean, using my voice signals, such that what you need not have a key for anything, so that the security of a vehicle can be maintained, because when the key is taken by somebody, others can maybe. So of course, most of the high-end system, they have this type of, like with a voice commands, you can control your vehicle. Control in the sense, at least you can unlock your vehicle, unlock the door of a vehicle and all those things. Is it a natural language processing application where I can generate some voice commands? I can give some voice commands where the vehicle will follow or act accordingly. Not exactly the driving type. I'm not automatic vehicles I'm talking about, but a
Yes, sir.
kind of,
It's speech recognition is there.
yes, it's kind of speech, but speech recognition where I'm using this natural language process with the help of whatever the signals that is being captured, signal. But of course, again, there's some signal processing, a bit of understanding you should have there, because any such interaction models we have, obviously you have to understand some signal processing methods. Okay, and similarly, next we have access online as well as stored information, like some other type of application already we discussed, and simple many other applications. But now, before going to next application, is it really easy to implement this type of application? Does it require highly expensive hardware or whatever it is? No, not really. Do you think so? Do you require, when we are taking such a challenging job using some natural
Yes,
language
sir. I
processing?
think memory and speed is a big problem.
Yes, but at the same, but the generating a prototype and showing that your device work and your model functions, I mean, your model works fine. That doesn't require, you can getting a prototype. You can take some Raspberry Pi or Arduino and just trying to encode program in such a way such that that prototype works normally, based on, of course, slight, I mean, a budget may be required, but normally may not be very expensive, because hardly you can take some online data repositories and try to get this type of communication happens and show that the system functions in a prototype mode, and let us see how it works later in high end scale. But now may not be very expensive, but it depends on what type of dialogue system you are developing using natural language processing. Okay? It's very important to see. Most of the natural, like this voice commands for to the vehicles and automatic cars, and then interactive answering machines. So here, neural network and then swarm intelligence, genetic algorithm, they are very effective. And from not only that, fuzzy logic. Even you should have the second choice to be fuzzy logic compared to the swarm intelligence and other models which are expensive as huge space, computationally expensive models. Fine. So, in my opinion, your choice could be number one for neural network, number two for fuzzy logic, type 2 fuzzy logic, type 1 fuzzy logic. Okay. The future of human computer dialogue systems. I think I already given a lot of application. I'll just ignore this slide. We talked problems. Yes. What are the major problems of human to computer developers where you can hit with some or face with some machine learning models? Tell me now. One is accuracy, like I have already mentioned here. These type of models. What do you call this? Automatic vehicles and all, where we really require a lot of complex models and high accurate models. Certainly we are in need of I mean, they are developing this machine learning model which give maximum accuracy. Like when we say go left, the vehicle can't take right turn, something like that. So this type of accuracy, because for those applications we cannot define just like that as simple conventional models. You have to be ready with similar model. Okay. And then any other problems with this? I'll give a hint, like the problem of supervised learning in case of unsupervised patterns are encountered. Means what? If you have supervised trained data you have with you, and then if you are implementing for some desired purpose, then if you have some unknown label where you are not got the training in that direction, something like that. If you see the previous example where you are making the query processing in the that queries database were there, where similar that training was not given, the query database is not up to date, then obviously what happens? The computer can get, some unknown, you can say unknown assignment where it cannot give the proper recommendation to the user. Obviously, it cannot respond to the incoming requests which are not expected or which are not trained in the direction. So, some trained direction only the computer can act, right? Obviously. So, it's very, very important to make sure that happens. But of course, in such cases, we can reconfirm with the kind of dialogue system which we are developing. But the arbitrary input, mostly it's unsupervised learning issues, like I can say, mostly just for a similar type of problem we have in unsupervised learning. Wherever you are not trained, you cannot go in the smooth direction. Any other? Just don't think I'm going to discuss human computer dialogue system, because it has multiple dimensions. A lot of other applications. It is not only one application, like I've seen some medicinal application, some e-commerce application, and other type of applications. It's not just, it is broad actually. The moment I say human computer dialogue system, is a broad system. Okay? Now, our job is like from a arbitrary, input or a speech or whatever, when we try to get a different conclusions, it is difficult to make all these human computer dialogue system to get some accurate input signal and get and generate accurate output accordingly. Then some understanding varied responses for this call system type applications, and then the variations happen in the data streams. All those things are the challenges. Okay? And similarly, many other applications, like whatever, depending on phases. And the success and all, how it works and all, already we have seen how they do. I'll ignore this. Then some machine translation, already we discussed kind of applications, how a language conversion softwares we can develop with the help of each, and then other type of modeling we can perform here. Then some statistical translation where we require some rule-based approaches, and then some probability-based approaches, some natural translations, or some Google translations we require. How do we perform all these things? And most of the people use that Google translation and all for some this one. But actually, sometimes you can have even simple one. Rule-based approach is also good. It's fine. Now I think a part of that one. Then future of machine translation. What are the main challenges when you go for these type of human computer dialogue systems and all, or any other type of systems? All these goals I have already spoken here. So predictable text when we are encountered, that's fine. Now tell me, okay, maybe when we are talking about this training is not given in the direction, and when such a text comes into the input, voice input and or any other natural language inputted to the model, how to deal with that? Tell me that untrained directions in the processing of natural language processing. In the direction of natural language processing, when you get this untrained patterns, tell me how do you deal with that? It is as good as like you have some supervised learning model you have seen, and you have got all of a sudden some unsupervised data for a specific direction of models. How do you work with that? Tell me. Hello, can you hear me?
Yes, sir.
See, there are trends actually. The moment we say when we have no predictable text, then it may not work. It will work only with predictable text. Then how to deal with that? Because this is a frequent challenge you face in your natural language processing. Tell me how you have dealt with some of you, those who are already working in the domain of natural language processing. Tell me. Are you clear with the question? See, it should be interactive. Only then I can, get that you are understanding.
Can you repeat your question, sir?
Yes. Now, what is the frequent challenge we face in natural language processing? Most of the existing systems, either NLP systems or something like these dialogue systems, which use natural language processing. What is the most frequent challenge we face is what? They don't, act smartly, or they don't function properly in case of unpredictable text or input signals. Right? In that case, how to deal with? Tell me.
So there are many methods, sir. We have to go with the POS, that is part of switch. We have to check for the ambiguity.
Yes. Any
Um,
other?
yeah, there are multiple methods to find it out that because it's that's why NLP is hard to understand because we can't predict like that what exactly the meaning of abbreviation suppose.
Yes.
So the training, the NLP model itself is a we are still I think research is going on that because every day the new words comes into the picture
Mm.
because of the social media.
Yes.
So that is one of the issue. But there are some things, some sparsity of the data, this kind of issue is also there. So I think few methods are there, like we can use a probabilistic model.
See, now have you heard from supervised to semi-supervised to unsupervised? When
Yeah,
we are
yeah,
going slowly the tougher side.
hmm.
Supervised to semi-supervised to unsupervised.
Yes,
Now this is like when you have trained NLP model, it's like supervised. I have trained
yes,
enough. Now when you get some awkward, some different odd, unpredictable text, but still some particular patterns are there in the text by which you can generate what exactly the internal inherent meaning of the natural language that is being given to you. It will go semi-supervised.
yeah.
But if
So
it's
in
complete,
unsupervised, so if it comes under the unsupervised, but obviously we are going to make a clusters. So we'll see like that the probability of that particular word is matches to that particular cluster.
yeah,
So
yes, that's what I was expecting from this phase. Now see your NLP models are trained already. Now when you go these unpredictable spontaneous conversations and then odd observations are noted in the input text or input signal of your system or data acquisition system, then what we do, we try to go from semi supervised to semi supervised, or then you can unsupervised, where you can use these unsupervised models. And sometimes you use people call self supervised models, where they can try to generate something like, I did not get my actual predictable text. I'll try to see what is the inherent meaning of this natural language processing, and I try to get some self supervised learning. Fine, which will give you some kind of idea about what exactly the text indicates or what exactly the meaning of that. Then accordingly, you can at least move towards semi supervised side. Then you can use all the supervised or semi supervised models, all those things. Fine. So, because now if you see, if not exactly the same, if you take some non-linear data, when you go to higher dimensions, in a sense, you can make them to linearly separable. Not exactly, of course, same example here, but just when you have these type of unsupervised learning complex models or data set given to you, now we try to map it to such a level such that at least you can go to semi-supervised learning model to check how it works. Because now you have to sensibly apply where to apply supervised model and unsupervised learning models. Since you have luckily a lot of unsupervised complex models available to you, you can somehow see whether they can be mapped to this type of challenges where you have these spontaneous conversations occur in your natural language processing, which will cause a lot of confusions and misunderstandings in the text, by way of which you will make wrong conclusions in your final system calls. That's how we have to understand these type of changes, and then suitably use supervised, semi-supervised, and unsupervised learning models. Okay. So of course, but this is a challenge, frequent challenge we used to actually get in any NLP modeling. I'm sure many of you are facing this type of problem because dealing with this ambiguity by a conventional modeling, and then the syntactic irregularity. What do you mean by syntactic irregularity? Tell me. Because sometimes the syntactic structure which we use in this linguistic processing of natural language processing, what happens, some particular meaning of a word can give a different indication or meaning compared to the previous line or previous para. So obviously what happens, these irregularities will be difficult to, because they give contradicting opinions, right, in the natural language processing. So obviously we have to understand how to deal with such a irregular expressions or words or sentences that normally occur in your natural language, which you try to process with the help of some machine learning model. It is as good as a supervised learning problem where we say some record so and so parameter happen, some class one, some other it is exactly different parameters happen, dimensions happen, and same class or different class. There's the contradicting models or contradicting features coexist in your data set with the help of which, or because of which you are facing this type of irregular expression being generated in natural language, which makes it very tougher to analyze and then model. Okay, but of course there are conventional frequent problems that you try to handle, and in specific problems again we are going to come in the next slides. Any other doubts here so far? Hello. Can you hear me?
Yes, sir, you're
Yes, sir, we can hear, sir.
Yes. Now, I think this example is already discussed now. Now, when you are going with this type of machine learning models to be used, you are just now selectively how to use just all the typical problems. You have to understand what type of tools we are using. There is a linguistic type of analysis and making, or psycholinguistic, philosophical analysis, computational linguistics, and all. What type of typical problems they are going to be existed in this one. Then normal linguistic analysis, what we do, we try to see how the words from the phrases and sentences to be generated, and what constraints are going to be having some possible meanings in a sentence. What constraints, what exactly the challenges in particular meaning generation of a sentence and all those things. So for this now, whether you use some feature extraction model or some dimensionality reduction or any other feature selection models, mostly here we try to go for some feature extraction models. Then we have what type of tools we use for which application, and try to find the meaning of that. And then what type of mathematical models of structure and meaning we try to establish here, with the help of which we try to get possible extraction of these phrases and sentences from the natural language processing. Then similarly, but I don't think everywhere uses linguistic or psycholinguistics or somewhere where we are making this deeper analysis of this one. Because of psycholinguistics, how do we perform these structure of sentences where the word and text meanings are identified? But it is not so easy, right? Because the same word can have different interpretation of meaning in a different scenario. Of course, in the same sentence or text document which you are referring for the same problem. And similarly, some experimental techniques where we are trying to measure for human performance, some statistical analysis of observations, how do you do here? All those typical issues we have to understand carefully before we go for, using suitable machine learning model. Then some other philosopher type analysis. We are going to see what is exact meaning and how do words and sentences, because now I'm doing the trend, what type of analysis people are making out of this text or input signal they are being generated, right? And what is the exact meaning, and how do words and sentences acquire that particular one, with the help of which we can make the possible analysis. And how do words identify the objects in the world? All those typical challenges we are going to understand here. Then we are making natural language augmentation here, everywhere. See, these are not direct. Now I'm not talking about exact machine. Now I'm talking about challenges where somewhere you use some feature extraction model, somewhere you use some supervised model, somewhere use unsupervised learning model, etc., etc. And finally, computational linguistics, very important phase of your analytical processing, where we are going to find the structure of sentences, how we are going to identify that. Then how the knowledge and reasoning we are going to model here. And at the same time, how a language can be used to accomplish a specific task. All these challenges. Of course, everywhere you're going to use different modeling also. Okay. And here, what type of tools we require? Various analytical algorithms, some data structure, and some simple formal models of representation and reasoning, and various artificial intelligence techniques we require for search and representation methods, of course, obviously, because most of the searching happen here, the search space is enormous, right? And now most of the trends we have seen and possibly some of the applications. Now we are going to discuss some NLP applications, some other NLP applications. Finding the appropriate documents on certain topics from a database of text, we already seen that. And any finding relevant books in a library. And obviously you can see the possible text document and see how this type of application can be generated, and then extracting that some kind of information or from a different type of messages, or maybe some kind of article collection on different topics, so that we can make some kind of analysis of the opinion or sentiment or something like that. Okay, when you try to build a database of maybe some stock market operations or transactions, based on those statistics we can perform something, right? This particular kind of investment have certain profits, so on, so all those applications you can generate. Then translating some documents from one language to another document, another language, all those things. But actually here we try to really need some highly accurate models. The reason is if it is some sensitive confidential document or some sensitive document where some newspaper article, something like if I am referring some article published in different language and simply converting, transforming into a particular language of different type, then you should ensure, otherwise because the meaning can get changed. Like I already mentioned yesterday, various examples in the previous session. So one particular word can give different meanings of ambiguous structures. Okay, so they are all different, but they are conventional. Whatever I shown in the previous slide, they are conventional. Similarly, some other algorithms like question answering systems, kind of human dialogue systems, human computer dialogue systems, where we are using our natural language for a query database, and then similarly automated customer service over the telephone, like kind of approach, where we take the input audio signals from the user point of view and try to process them in a linguistic way, where the analytical processing try to help you to identify a suitable good customers, and the customer will be able to get a better goods and at a better cheaper price. Not exactly kind of e-commerce, but other application, customer satisfaction, feedback survey, and other details. Fine, many other. And the genuinity identification, like linguistic, when you are processing, somebody gives a feedback about somebody, is it really good or bad? Genuine or not? How you are processing the natural language over there. Then spoken language control of a machine, how can we do that? For some voice control machine of a VCR or a computer, how we can make it? And many other applications are there, where we are going to understand typical structures of these mechanisms. Some recommendation systems. Now, in natural language processing applications are very crucial in recommendation systems also. Subject to what type of analytical processing models you are using to properly analyze the natural language that is being collected by the system that you are using for recommendation system. Okay, some other prototype applications which we can now. Production application we have seen, conventional application. Now prototype level applications, where computers grade the student in a particular, representation or some examination compared to human grades. Now, which one is good? You tell me. Human grading or computer grading? Why do I really need a person to evaluate? Now, with the advanced growth in the artificial intelligence modeling, when we can take this particular text document and use some image processing models and try to evaluate the scripts. Because if you see nowadays, if some JE examination, and if you go with the subjective type examination, it is very difficult to understand the natural language and difficult to make the evaluation. So when the computer grading system you can develop for a student examination, small scale for now, then how can it be different or better from human grading mechanism? Kind of. It's a prototype level applications where people started working on that, and then some automated reading tutor intervenes, how they are going to understand, and they will see if the students are really understanding, and are there any mistakes here, and the reader makes the mistake, how to identify and how to take the help and all those things. Then what happens, human feedback system, you can say, like similar way, like I will ask a computer to watch a video clip, maybe some soccer game or any other, some IPL game or any other game, and I'll ask the computer to give a report or a feedback, not human perspective I'm talking about. Computer watching something and giving a feedback, kind of. But how do you make this type of data to be a linguistic type of analytics what you're performing here? Then similarly, when we try to develop a system that predicts the upcoming words and try to expand the abbreviations to help people who are trying to, who are with disabilities and to communicate, so that they need not to take a lot of efforts to, write or speak, whatever it is. Okay, this type of supporting system, I don't call it as a recommendation system, slightly a supporting or assistance system where a computer can predict the upcoming words and expand the abbreviations to help the people of such disabilities such that they can communicate easily to whatever the any extent talking about. So there are plenty of applications we discussed everywhere, and we are going to use this type of modeling which we discussed as of now. I think we have done 1 hour. I'll just wind up in another 15 minutes so that I will leave for question answers, because yesterday there were heavily audience asking a lot of questions. Are we clear so far?
Yes, sir.
Okay, this session I will leave 10 minutes early because yesterday there are so many questions you were asking, right? So we had no time the other day. Today I will leave 10 minutes early. Now, meanwhile, now NLP for some information retrieval or some web search type of applications. Now, information retrieval is one of the crucial component here, because we are trying to establish some kind of understanding of the sentence and then trying to extract useful features and thereby information, and then make some knowledge discovery. So all these things we are going to understand, and also like some recommendation system for user computer interaction, and then some searching of people are searching for an item or a good, and then some particular patterns, data patterns, how we are going to understand this behavior. The semi-supervised learning. Why I'm talking about semi-supervised learning is because of the complexity that whatever I discussed, the unpredictable text, and when you have this no labeled information much available onto the tokens or the lexical analyzed data that you have come up with. Because most of the concepts are pre-specified. And what about the unknown patterns, and how do we try to get this type of information, all those things? Then alternative, sometimes like I mentioned, is self-supervised learning, where the learner discovers some kind of information or some knowledge or concepts on the fly. What do you mean by on the fly? Because we have the supervised data is not sufficient to get the proper conclusion or definition or meaning from the natural language which you are trying to extract or process. You try to make some conclusions on the fly to discover the unusual and inherent patterns, so that you can make the better conclusions compared to the just a supervised learning model. And automatically you try to label the example. It is something like an unsupervised or semi-supervised, you are trying to add some labeling such that you will make a better interpretation of the data that you are trying to process for the analytical model. Okay. So now parts of the spoken dialogue system. I'll ignore already I have put a lot of time on this one this dialogue system, and but of course the system prompt, how it does and all those things you have to understand, but I will leave this. Then some natural language processing applications, some conventional applications, some core technologies where we use question answering, dialogue system, information extraction, information retrieval, summarization, sentiment analysis, language modeling, and many other applications. Now tell me, out of these, which one you feel complex? Which you don't know, leave it. Out of this, which you know the application, which you have heard of, tell me which one you feel very complex. Tell me. Tell me. I can hear you. Tell me. Anybody?
I feel language modeling will be.
Pardon?
Language modeling. Because once we have the language model, other applications can use that language model.
Yes. Any other? Okay, obviously many say sentiment analysis and then summarization and then syntactic parsing is fine. Maybe you can try to achieve the better useful tools here. Dialogue systems. So among all these, what I have observed is something like this: sentiment analysis, dialogue system, summarization. There could be possibly a lot of challenges involved in these three phases of research in natural language process. Okay, mostly, but of course, language modeling also one of the, because there are a lot of heavy image processing models you have to require here sometimes, and if it is a text document or any other, and in case of this other type of signal processing model when you use, and still it is also difficult to make it. Particularly in Indian language, a lot of diversity is there. Obviously, you have to have a lot of challenges involved when you are going with the language modeling and multi-language, multilinguistic analysis and all those things. Having seen all these applications, one can say that the natural language processing normally it is a kind of domain that lies at the intersection of computational linguistics and machine learning models. It makes sense, right? Makes sense. Having seen all these applications of linguistic analysis and then is used in machine learning, we can say that it is the intersection of these two, lying at exactly. Okay. No. Any doubts so far? Hello?
Sir, I wanted to talk about
Yes.
it in a layman's language. May I?
Yes, please. Sure. Tell me.
सर कल हमने जब डिस्कस किया था तो हमने ये देखा था कि जो नॉर्मल हमारी प्रोसीजरल प्रोग्रामिंग है और जो हमारा मशीन लर्निंग है तो उसमें हमारा बेसिक डिफरेंस ये है कि प्रोसीजरल प्रोग्रामिंग में इनपुट और प्रोसेस हमें देना पड़ता है और आउटपुट वो जनरेट करता है और हम चेक करते हैं कि वो सही जनरेट हो रहा है नहीं हो रहा है और हमें सही जनरेट हो रहा है तो हमारा प्रोसेस
Yes.
ठीक है।
Yes.
मशीन लर्निंग में इनपुट और आउटपुट हम दे रहे हैं, प्रोसेस वो खुद क्रिएट कर रहा है।
Yes.
और जब हम डीप लर्निंग की बात करते हैं तब तो हम फीचर एक्सट्रैक्शन भी नहीं करवा रहे हैं, वो भी ऑटोमेटिकली हो रहा है। तो वो कैसे हो रहा है, मतलब वो थोड़ा सा कंफ्यूज हूँ मैं उस चीज को लेकर।
नहीं, अभी आपका डाउट क्या है ना, मतलब हाउ यू आर गोइंग टू make this feature extraction,
input and output to the machine and it is generating the process itself.
Yes.
Either we talk about machine learning or deep learning.
Yes.
So how is it done by the machine?
Now, have you studied conventional neural networks, feed-forward neural networks, and deep learning with autoencoders, principal component analysis? All those things you have studied?
Yes, sir. I have a little idea about these things. Some feature extraction is there, and in case of machine learning, feature extraction is there, but in case of deep learning, feature extraction is also not there.
Madam, deep learning, you can use this autoencoders and all, stack of autoencoders for this dimensionality reduction and feature extraction. So, maybe after 2 slides it will come. I will explain that time. Okay? Now, our koi query hai ye chhod ke? Feature extraction I will talk after a couple of slides. Any other? Hello? 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 Other participants, can you hear me?
Yes, sir, we can hear you.
I think madam has left. Maybe I don't know. I think her query was like now conventional neural networks and other feature extraction models. She was aware of that. In case of this natural language processing, how the feature extraction is performed, particularly using some deep learning and all, she was, not clear. And I will explain when we come, when we go to that slide. Maybe after a couple of slides it will come. Okay. Now, I think you have done already this one. Now, similar to this one, some other machine learning models also we can use to deal with this some human computer interaction type model where we try to integrate with some feedback type of system or some kind of like there are some paralyzed person or immobile person, locked in person who cannot move or walk. They may have some little they cannot speak fluently like us. Then how to make this natural language processing, and everybody's language is not same for such a disability patients or persons, how to make this type of technology useful to them. Well, all those applications. So we are now here we need to decide what type of signals you are going to collect. Like some brain signals I'm going to collect, EEG signals, and try to integrate or correlate with some and I mean natural language, what they are speaking, and try to see how genuine they are. Their thoughts are something and their speech is something, and then fMRI and all type of data sets, because sensing the brain and seeing what is the correlation to their natural language and all those things. So sometimes EEG signals, if it is a human computer interaction model. And now the question is like, she was asking like, why deep learning? Why not other learning models? Tell me, what is the main advantage of using deep learning? You tell me.
Sir, my opinion is again same that feature extraction is not required here. But
No,
how
feature
you are
extraction not required, we never say. Feature extraction is required. For example, when we have, see, if you take your input layer neurons, when you have large number of neurons, because when you have particularly these data sets like this natural language processing, once your tokenization is done, when you have large amount of tokens are available or these features are available, certainly you may require feature extraction. But there in the input layer of deep learning, maybe you can use some bias spot optimization algorithm. When you go down, sometimes if you can't filter them so easily, or if you can't extract them so easily, when you go next level in the layered architecture of your deep learning, like there are 10 hidden layers, maybe you can use some stack of auto encoders. So you can use auto encoder based deep learning where you are going to use the dimensionality reduction. It is there. Oh, next slide may have. So I will just come back. So there also feature extraction you can do, obviously dimensionality reduction. Obviously you are doing. So deep learning is not only for classification, you can also use for feature extraction. Fine. So लेकिन उसके लिए आप तो high level programming that all the problem, because it's not so easy like your conventional programming of your feed forward neural networks and all, feedback networks and all. It's slightly little complex, but it's not very tough. So now let me go back to the question now. Why we use deep learning so heavily, not others? It is very, very clear, and we are all the same opinion that neural network is very, very useful in natural language processing, obviously. Okay,
Sir,
why?
a lot of data is required in case of deep learning, and nowadays it is easily available. That may be the reason.
Yes, madam, you are right in one sense. Like when you have large volume data, deep learning is more effective, like I said. But actually, why deep learning in sense? If you have a very small amount of data, where we don't have much training and all, obviously what happens, deep learning may not be so effective. You can go with a simple conventional neural networks or any other type of similar machine learning model. But when you are going with complex deep learning model, see, if when you have this large amount of data, when you are trying to increase, like these application NLP, you have real-time text documents or web mining pages are coming, and some network data is coming on together, some similar type of data. Just an example I'm giving. In case of NLP type application, this is a real-time data, real-time collection of some patients' data, real-time signals, like we have seen EEG signals, where you are attaching a wearable sensor, some IoT type of system device you have. In such cases, it is going what? It is going, the performance of this algorithm or deep learning models are always increasing, or you say performing, when the amount of data is also increasing. Or if you see the graph, you see the performance is increasing always with the help of the growth, with the amount of data is increased. Where in case of all other learning algorithms, everything, because any machine learning model, only two types, whether what you call iterative, non-iterative. That's all. You take any machine learning model, either iterative or non-iterative. That's all. Now here, any other learning algorithms you take, with the amount of data increase, the performance will also increase. That's all. In case of deep learning here. But in case of other learning algorithm, it may not be same. After a certain stage, it may decrease or it may be same, but it will never increase. Fine. It will never be. Then in case of deep learning, it will always increase, because for large volume, it will give better training and better, better layer by layer computation happens, and you have better extraction of the information. Maybe computationally efficient, computationally expensive, deep learning. But the performance is always increasing. Whereas other learning models, it is always, it will decrease over a point of time. That is a major challenge which we have here. In other cases, it works normally. Now, if you take this one, some deep learning with a stack of autoencoders. Now, if you see previously, like what if you say, deep learning we call it a universal approximator, because it is a provision for hierarchy of features, where features we try to combine and aggregate from one layer to the next, where we are trying to get a better approximation or better conclusion of the features or the data set. Where in case of this DNA is suitable for problems which consist of plenty of unlabeled data and some good amount of labeled data. That's all. That's all. If you take this deep learning conventional architecture, how it looks like, where I also need some feature extraction. If you see the first deep learning architecture shown, how many layers we have? How many hidden layers we have? You tell me. 2 hidden layer, input layer, output layer, hidden layer 1 and hidden layer 2. It's a multi-layer architecture, of course, deep learning. So here what happens, a deep learning with some stack of autoencoders and then we train them in a supervised way, layer by layer. How do you do that? Normally, what you can DNA we consist of a stack of autoencoders where we are trying to what you can say reduce the number of features by passing through each autoencoder. If you see for hidden layer 1 we have autoencoder 1, hidden layer 2 we have autoencoder 2. And what we try to do, we try to reduce the number of features, and we are where we are trying to pass through each autoencoder where it is trying to minimize the number of features. Similarly, autoencoder 2 for hidden layer 2, and we try to reduce this one. Actually, feature extraction you can call it as a dimensionality reduction also. So deep learning can be used for this purpose also. Of course, but it is a prerequisite part of the this one classification problem, because features define the notion of the classification, right? Obviously, not understand. So some algorithm, how can we propose for this type of applications? Like if I want to go for a deep learning architecture with some novel aggregation functions, how do I do that? And then some activation functions. You can propose new aggregation function, new activation function, and perform better and better complex tasks here. If you see, there is some new multiplicative aggregation function we have proposed here, and I would try to aggregate the values from the input weights of the neurons, and then it tries to, if you see, there is something called row ij we are using. What is row ij there? That is a novelty if somebody is asking. It denotes the correlation between features xj and xj. So when you are trying to aggregate the feature values, we try to go for what? What is the correlation between the features, so that what happens, you are going to aggregate, you're going to see how the dependency is there among the feature values, so that what happens, you can try to use this information for better classification. And Vij is what? Is a weight from ith input neuron to jth hidden neuron. Double jar is what? Weight from jth hidden neuron to ith hidden neuron. Something like that. Of course, it's a kind of where those who want to use, they can, some deep learning models, and they can propose different activation aggregation function and see how the natural language. Similarly, some swarm intelligence models they can use. I'll just quickly wind up this one. So now when somebody talks about like feature extraction and feature selection, when we are going with these complex by randomized algorithms like swarm intelligence models, it is very, very prominent to use these type of randomly search based algorithms, because the search space is enormous. Normally, if you take any computationally expensive problem like natural language processing, obviously we are in need of this. You come at 3:30, yeah? Hello? 3:30. You come at 3:30.
Yes, sir.
So here what happens, this type of randomized search method where some population we are trying to establish and see a particle is representing something, maybe a kind of token or something in your natural language document, something like that, and try to map it to your NLP problem and try to make how the robust evolutionary optimization technique you are using based on the movement and intelligence of swarms. How many of you know what is swarm intelligence here?
Again, this is an optimization kind of thing. Swarm intelligence means searching for food with the covering minimum distance or using minimum energy.
Yes, now we're talking about optimization, right? Now, do we need optimization in natural language processing? Obviously, do you agree?
Yes, sir. For decreasing the time, for decreasing the usage of memory, you may say decreasing the complexity.
No, not only for computational efficiency, but also for highly accurate, these text models and all this. And obviously, we require optimization is very, very important in natural language processing. Therefore, you can conveniently use all these swarm intelligence models, binary optimization algorithm, evolutionary computation everywhere. Because why they're calling this optimization algorithm? Because these type of models normally we select in case of large volume data set, because the set space is high and you're not trained enough. And particularly, let me highlight this one. These type of models where you have no much training is given. If there's not a supervised model where you are trained on much, therefore these type of models are more adaptable, and where you can deal with some kind of bird swarm optimization. I mean, some other anti-colony optimization.
So when we talk about character recognition, how it can be used?
Can you repeat, madam?
When we talk about character recognition, how we can use this kind of algorithm there?
Is it character recognition you're talking about? What exactly?
Yeah,
What?
yeah. Character recognition of any Indian language.
Uh, Now, how using SWAM intelligence? What is your
Yeah.
question?
Yeah, any optimization algorithm, it may be PS or any other thing.
Yes, now what happens, madam? Now see, in every SWAM intelligence model, we try to develop something called a fitness function. I will show just 1 second. I will show there is something called a fitness function.
Yes.
Uh, this is this graph of this function. Now, now what happens? We try to adopt the suitable bind spread optimization algorithm as SWAM intelligence PSO. Then we try to develop a fitness function, objective function. Then we try to map for which particular feature or for which particular value of this one the objective, or for which particle the objective function value is high or the more fitness. Then we are going to see for this particular direction of the information, or for this particular what you can say feature set, we have the dominant information, and we are going to map this particular classification accordingly. So the particle for which the fitness function value is high, I mean optimum, you can say high or low, whatever optimum, for those particles you are going to consider in the process. Now accordingly you can see what is the character recognition and all this, you can map it. Similarly you can go for speech recognition or character recognition according to the input, according to the type of data, whether it is a signal or whatever it is. But only thing is what type of algorithm you adapt to this type of problem, it always very important. It is very important, because accordingly you are going to, I mean, make the proper conclusions here. Now our job is what? Global optimum. Like you mentioned, some particular character recognition you are trying to make. So out of this possible, I mean, character which will try to indicate certain behavior of human perception or linguistic information. Now which one is actually optimum? Which one is optimum, or which one is highest? Then accordingly, our job is the highest peak in the space which you try to search, which will give you most possible, most prominent information from the tokens or something which you have established or extracted from the lexical analysis. So it's a simple pseudo code. Of course, we have no time. Actually, it is supposed to be, I mean, given for, I mean, 2 hours time on PSO, so that you can better understand. Now, quickly, I have given a brief introduction. Now, because it is very important to understand this type of modeling, how do they function based on SWAM intelligence? Because, like it's mentioned, the fitness function first will confer personal influence and social influence. What do you mean by personal influence? If you are reading a particular sentence, if you have a text document for natural language processing. Now, what is the personal influence? What is the social influence? If I take a particular sentence or something in a same text
So
document,
social influence
based on
overall, all social influence is something like global, the influence of all the particles in the area.
yes.
And
See, now what I will give you, for example, I'm making some sentiment analysis application using on some text document, some situated data, whatever it is. Now, some personal influence. What do you mean by that? I will try to see what exactly a particular tweet indicates. You try to make some conclusion out of this one. Then what is the social influence? And now same tweets are the whatever the tweets tagged in this particular tweet, or I can say when you are tweeting by sharing that particular image or tweet, all the others how they are responding. What is the social influence onto this one? Then it is the inertia plus I mean personal influence plus social influence. And finally, what is the particle position at time t plus 1, v of t plus 1. Then what happens? Okay, if v of t time this happens, this is a personal influence, this is a social influence. Means you can conclude, finally, this is a sentiment analysis. I mean, you can have out of this one, the given document. Maybe a text document or some Twitter data or any other social mining data. You can see this is the inertia of time t. This is a personal influence. This is a social influence. Then therefore you can decide which could be a possible, I mean, understanding of the statement, and then you can close it, right?
yes, sir.
So normally this inertia indicates what? It makes the particle move in the same direction with the same velocity. Personal influence what is makes the particle and of course all are and then what happens, it makes the particle return to the previous position better than the current. If you feel something is like not again, you'll go back to some other tweet or something and come back. And social influence is what conservative means, what like makes the particle follow the best neighbor's direction. You see, among all the persons who are tweeting as a reply in the social influence, who is the best one? On a social influence mode, who is going in which direction? Then what could be the best possible move here? Of course, I'm just taking a sentiment analysis example here, but similarly, you can map it just for your better understanding. I'm taking. Why I'm asking is these type of optimization algorithms are most adaptable for these type of natural language processing problems. Otherwise, it is very difficult to make this type of modeling without even optimization. But of course, there are some rules we need to follow when we are trying to make this type of optimization modeling. Like we should avoid collision with the neighboring birds, and similarly, we should have velocity matching. What do you mean by collision avoiding with the neighboring birds? Like when you are making some sentiment analysis, and when you take a particular Twitter account and you have some of your followers or friends, then you see what is their tweets, and you should be going with their opinion mostly because you and your friends have the similar type of nature here. Then what happens? Velocity matching, match the velocity of neighboring birds. You see what happens in the similar documents or similar sentences in the lexical analysis and see how they are going. In the same way, we try to understand the linguistic information, right? Similarly, flock centering, stay near neighboring birds. You should always be close to the neighboring birds or neighboring particles so that you can have the useful, accurate information. Is very, very important. And then some characteristic we can use, that's all. And similarly, we can also use some technology, some virtual reality and augmented reality type of hardware based on natural language processing, some speech conversion. I can give a command accordingly. This particular virtual reality and hardware reality, hardware can be, working onto this one. All these applications one can perform here is very, very, very important to deal or understand them. Then similarly, kind of automobile applications where virtual reality, this natural language processing can be understood by just taking some input images and shown to the computer, and computer can suggest some changes, and you can also ask the computer for this recommendation system to perform certain changes and all those things. So I'm done now. Any doubts? Let me know.
Yeah, thank you, sir. I request the participants, if you have any queries or doubts, you can post it in